Welcome back everyone to another LeetCode problem solving video. Today we're solving this Amazon question, I would say Meta, Microsoft, Asana, Apple question. Product of array except self. Very interesting question, I would say. I solved this question, I believe, last year. I'm not sure I quite remember the approach, but we'll read the problem and see how far we can get. Hopefully this video provides some value to you. If that's the case, please thumbs up and subscribe to my channel. If you're new here, welcome. I'm Enrique Barkley, aspiring software developer. I try to solve these LeetCode problem questions and put it out there for you, and also to look back in time and see how good I've gotten solving these questions and, getting better every day. That's what we're doing here. You're going to see me make mistakes. You're going to see me over-explain things. That's also for me too, but try to provide as much value as possible for you as well. So let's go ahead and jump into the problem description. The problem says, given an integer array nums, return an array answer such that answer at that index is equal to the product of all the elements of nums except nums at that index. The product of any prefix or suffix of nums is guaranteed to fit in a 32-bit integer. That's interesting. You must write an algorithm that runs in linear time and without using the division operation. Okay, before I go into the examples, a couple things that caught my eye here is the fact that we're talking about it's guaranteed that it's going to fit in a 32-bit integer. In Python, we don't have to worry about that because that's pretty much saying it's making sure we're not going to have integer overflow, okay? If we were using, I don't know, C++, we could think about having maybe an edge case to avoid this thing to happen, but since it's guaranteed, also, you don't have to worry about that if you're solving in C++. We're going to be solving it in Python today, but that's a pretty good, I don't feel all medium questions do that at this level, but that's pretty good that that's there. Also, another thing is that it's talking about prefix and suffix, okay? So to this point, if you know a little bit about some algorithms, you probably would have gotten a hint from this. And what I mean is we can do a prefix sum where we can try to solve the problem using a prefix sum algorithm or a suffix sum algorithm. Now I'm saying sum, but we're talking about product. So that might be the modification we would have to apply. Let's go ahead and jump into the constraints and see what the problem's asking. So constraints, the array is going to be from 2 all the way up to 10 to the 5. So very large array, makes sense that we should solve this in one pass over the array, okay? Large numbers from -30 all the way up to 30. And the input is generated such that that answer at that particular index is guaranteed to fit into 32-bit integer. We saw that. Follow up. Who doesn't love a good follow-up question? It says, can you solve the problem in constant time, extra space complexity? The output array does not count as extra space. Okay, I had to think over there because obviously, here it's asking for an answer array as a returning array, and we get the nums array. So, but that doesn't count. So if you were thinking about trying to solve this using a hash table or some sort, that's not going to be the case. We're going to have to iterate over this array one time and add that product of all those numbers to an answer array. That's what I'm thinking so far. Now, let's go ahead and check the first example. And it says input array 1, 2, 3, 4, output array 24, 12, 8, and 6. So except self. So let's say, from the get-go, let's say we're going to start iterating over this array right here. So how do we get to this point? The first thing I'm looking at is if I start iterating over this side of the array, I multiply these three numbers and I get 24. 2 times 3, 6 times 4, 24, okay? That's good so far. But what happened is when I get here, I can multiply these two, but I would have to also look backwards. Now, in this array, it would make sense I could say look backwards the same amount of steps you're moving forward, meaning if I move one step forward, look backwards one step, and then multiply that with the next two items. But then I'm jumping around, I feel like, because if I'm here, I can look backwards. I move 2 spaces, I can look backwards 2 spaces, multiply those two, and then multiply that by the subsequent element next to where I'm standing, and so forth. But again, taking the hints from the question, prefix and suffix. Prefix sum or suffix sum, those are very, I would say, powerful algorithms because they help you calculate products or sums in constant time, in a sense of you can just store, as you iterate over the array, you can store this product, in this case, on that particular pointer, on that particular variable, And then from there, you can just fill your output array with this running product or sum. In this case, it's going to be obviously product, but I've seen this problem with sum, and that's kind of where I'm assimilating we're going to go. We don't need to solve for extra space and so forth. So what I'm thinking is here, talking about prefix and suffix, why don't we initialize a variable and just let's go with this. Let's initialize a variable that we could iterate for. Let's say we're going to create our answer array, and we can iterate for every number starting, let's say, from here, and then, you know, we would hold the product to till that point of that element, everything to the left. For instance, let's say we want to get the product of 1. Well, we would have to calculate the number that was before 1. There's nothing before 1. So we could simply start our loop from 2, okay? Because that way from 2, we can get the product of what's before 2, which is 1, okay? Then when we're at 3, we can get the product of everything before 3, which is 2 and 1. And so forth. When we get to 4, we get the product of these 3 numbers. Now, that's not going to give us all the answer because, for instance, we know we can't start from 1 using this approach because there's nothing to the left of 1, okay? And then let's say we're going to start from our second index, and in this case, it's going to be the product of 2, and the answer array would be 1 because there's just 1 to the left of 2. Then we move up to 3, but then we get the product of 2 times 1, which is equal to 2. So in our answer array, the answer for 3 is going to be equal to 2. We move to 4. The answer of 4, it's going to be equal to 3 times 2 equals 6 times 1 equals 6. So we can see that when we get to this point, we get the answer of this. Now, what happens if we also do a suffix process? Meaning we're going to do one pass over the array going leftwards and one pass over the array going rightwards, and then from the left, or from the left first and then from the right. You might see this flip on the camera here because I have this flip here, so I'm trying not, if you're looking at my hands motion here, don't get confused. This is flip for intentions of the direction I'm looking at the screen, okay? So just don't get confused by that. But anyways, moving forward with that. So we have 6 here, we have 2 here, right? Because we said at 3, 2 times 1 equals 2, right? We have 1 here and 1 here, okay? And let me go ahead and put that here so we could start looking at this process. So let's say we're going to start our answer array, okay? It is very possible that we need to start this array as the same size of nums. We're probably going to be storing numbers in that answer array until we do the second pass, okay? Which is the first pass, as I said, is going to look like this. So we don't have anything to the left of 1. So we could say 2 times 1. So we could say 1. Now when we're at 3, we have 2 and 1. So when we calculate the product of that, 2 times 1 equals 2. We could add that here. Now when we get to 4, we could add the product of 3 times 2 equals 6. 6 times 1 equals 6. So we can add that here. This would be our first pass over that array, okay? And what I mean by pass is, even though we haven't found our answer, we don't have to do a nested for loop, okay? So if you were thinking about time complexity, you know, if we're talking about doing one pass to the left and then doing another pass to the right, these loops are not nested, okay? So we're not really iterating over the array twice. We're iterating over the array once to the left, accumulating those numbers in one answer array, and then iterating from those numbers from right to left, and then accumulating the product of that in a new array. That is technically big O of n, because we're iterating over the array once for every element and storing the result. The problem would be if we would have to use a separate data structure, because we would have to pull from that data structure, meaning we would have to iterate over that array once and then iterate over, let's say, a hash table where you're storing the products, right, of each number by its position, which might not be the best approach, to be honest, because the best approach here would be using division operation, where you multiply all the numbers and then you divide by that position, particularly in your nums array and your answer array. But obviously they're saying not to use that. So a left pass with the prefix, storing the prefix as we did here, it's one solution. Now we're going to do a second pass going rightwards, okay? Or backwards over the array. So that would look like the following. Let's say we're going to create a variable called postfix and we're going to initiate it by 1. Why by 1? The same reason we started our loop here at position 2 instead of 1. There's nothing to the left of 1, so we can't count anything for 1. Same thing when we start backwards. There's nothing to the right of 4, and we need the numbers up to that point from the right, okay? So we would start postfix at 1 and make sure that when we multiply by 1, we get the same product. So when we're standing at 4, we're going to get the product from the answer array 6 right here, and we're going to multiply that by our running product, which is the postfix, okay? With 6 times 1, it's going to be equal to 6. Okay, so that stays the same. Remember, this is our output array. This is our running array. So this array at the end would look like this, okay? That's what we're trying to simulate here. This is our running product so far. So essentially, since we are storing the product from the left side here, we're going to multiply everything from here by the running product over here. And the running product from here, we're going to be multiplying by the input array over here. So that way we grab every product from here, store it in postfix, update it, and then multiply that by the running product of the left side. And what we're doing here is basically we're going upwards, calculating the product of all these numbers up to that point, okay? So again, when we are at 4 coming from the left, we calculated these 3 numbers. When we're at 3, we calculated these 2 numbers, and so forth. So we store that here. That was the first step. Now, as we iterate to the left side, when we created the postfix here equals to 1, because starting from here, there's nothing to the right, our postfix is going to be multiplied by the input array at this point, okay? So let's say we're at 4, okay? 1 times 4 equals 4. That's going to be the running sum for our postfix here. So now we move into the next point, which is 3, okay? And now here we're going to multiply 4 times 2. It's going to be equal 8. And as we can see here, that is our resulting array. So this becomes 8. Now we'll multiply our postfix 4 by 3, okay? And that becomes 12. So that is what our postfix is going to become. Now at this point, we multiply 12 by our answer array. 12 times 1 equals 12. So that is what our position, the second position here is going to become. And finally here we update this 12 times 2 equals 24. So our postfix becomes 24. And at this point, we multiply 24 by 1 and it's equal to 24. So as we can see here, this was the resulting array. Our postfix at this point don't really matter anymore. We found our solution, and that is basically how we're going to be solving this problem. In code, it might be easier to understand once we're coding it, because you're going to understand where certain things are coming from. Okay, let's start coding our approach. I'm going to leave this here for the sake of the example. The first thing we're going to do is create our answer array. Once we initialize our array, notice how we're initializing all with ones, okay? So instead of initializing the array empty like this, we're going to initialize all by 1 and multiply that by the length of our array. This is going to give us a neat array that is the same size as our input array. Then the next thing we're going to do is we're going to initialize that left pointer. So we're going to initialize that at 1, and then we're going to iterate over our array. And we can iterate in the following way, where we can start at position 1, because again, we already know there's nothing at the left of the first index, all the way up to the length of num. Then we want to store the cumulative product of that left pointer in our answer array. And it's as simple as saying answer equals left. Now, the key here is to update our left pointer, or our left variable here, to contain or calculate that running product, okay? And we do that the following manner. We multiply left by the nums at I at that particular index, okay? What we're basically saying here is multiply this number right here by the position of the number in that index in our loop. For instance, we're going to start at index 1, so we're going to start here. We're going to multiply 2 times 1 is going to be equal to, So the second item in our list is going to be equal to, okay? So you kind of see the gist here of where we're going. And that's pretty much it for the left side of the product, okay? We're creating our left pointer, which is going to store the running product of the left side. We're going to iterate over the array starting at 1 because we know there's nothing at index 0. We're going to store that product in our answer array. See how we're doing that before updating this, because in the first loop, we know there's nothing to the left. Now in the second run, we update that left variable and it becomes the product, the running product of I. There is another cool way to do this, and I'm also going to show it here. So this is another way to do it, okay? And we're doing basically the same thing. We're saying the answer at that index is going to be equal to the product of the number at that previous index in the same answer array times the number at that previous index in the input array, okay? So we're basically multiplying the previous two numbers from the input array and the answer array and moving that needle forward. Okay, so at this point, we're done with the left part of calculating the product of the first pass. Now, in the second pass, we would have to create a postfix as we talked before. We're going to initialize that at 1 again, because we want to make sure every time we calculate something by the product, we have a number. There's nothing to the left of the first number. There's also nothing to the right of the last number. Okay. So we're creating that at 1. We're going to iterate now, and we're going to say for every item in range. But here, we're going to iterate backwards, okay? There's, again, multiple ways to do that in Python. Some people like to use the -1, -1, -1 to iterate backwards. I personally like to use reverse. And reverse is used in the following way. Now, I noticed something while I was writing this loop, and it's the fact that we're using length of nums, and length of nums here. Why don't we just create a variable to store that, and we don't have to compute that every time we go through it? Perfect. So with this variable, we can just input that here, here, and here. You know, that way your code looks more elegant and less cramped, okay? So let's move up with the postfix product. So the way we're going to calculate that is we're going to call answer and multiply equal that by our postfix product. At this point, we're making sure that everything as we iterate backwards gets computed and stored in that answer array. The next thing we need to do here is update postfix to compute the product. So in the next iteration, it update answer, okay? So the way we're going to do that is basically saying postfix times equal the nums at that particular index. Then from here, we're pretty much getting to the point where if we have the product of the left side, we also have the product of the right side. There's nothing really left to do because we're making sure we iterate over all the elements from left to right. We store the elements in our answer array. Then from that answer array, it's going to start with the range pointer ended. And I'm going to find a way to show this on the video. Then through here, we can just simply return our answer array. And this pretty much would represent the solution of product array except self, calculating everything or the prefix product of one side and calculating everything from the right side. This is basically an array manipulation technique where prefix sum, I would say, algorithm would be involved. It's some sort of intermediate algorithm. It's important to get familiar with it. I have to be honest. I personally struggle a lot to explain this because, I mean, even though I understand how it works and I understand how to code it, it's hard to understand how you manipulate the array from both ends. So if you feel like you struggle to catch the concepts from, you know, computing from left side and the right side, you are, I believe, in a normal place because that personally, it's my experience. So as long as you understand what's happening in the array, I think you're in good shape to solve different problems. I would say, you know, maybe try to solve the problem in 2 days and see how you feel again with the problem. But it's totally normal to feel like the problem, it's a little bit confusing, okay? So just try to be as straightforward as possible. Before I run it though, I want to show a simple simulation of how the code is going to look. And for that, I came here and basically just dropped the code here and example. And here I'm going to simulate how the problem is going to run with the first example, as we can see. So imagine we're going to take this input array here, and this is what we have here. So in the first iteration, see how we are creating a resulting array. We initialize everything by 1 and multiply that by the length of num. Something that I'm missing here is the variable I created at this point right here. But besides that, this is just for, simplicity of the code and make it look a little more elegant, but it's going to work the same. So next, once we create our array down here, all initiated at once, see how it's the same size as our input array. We're going to iterate over the input array. See how we start at value 1 or index 1. So I becomes 1 immediately. The next thing that is happening here is that at that index, we're going to get the product of the previous two numbers from the resulting array and the input array. This case, see how there's nothing to the left of 1, okay? And we're starting here, there's only 1. So once we multiply 1 times 1, it's going to be equal to 1, okay? So see how that doesn't change, okay? We go back up to the loop. Now we are at index 2. Again, we're going to multiply at index 2. We're going to multiply 1 times 2. Now index 2 is going to become 2. Great, we're good to that point. We're going to iterate again one more time. I becomes 3. And now at index 3 right here, we're going to multiply the previous two index. So you see how we're standing here and we're multiplying everything before that. When we work here, we multiply everything before that. So now 3 is going to be the product of 2 times 6, okay? Perfect, see how that's 6 there. So up to this point, we reached the end of that first pass over the array, and we have our product 1, 1, 2, and 6. So we're good till here. Now we move over, and remember we're initiating postfix at 1 because we're starting from the back of the array. We're going to iterate backwards, and see how here I use -1 instead of reversed. It works the same. It's just a Python method that we could use. It's very efficient as well. But again, postfix is going to be initiated by 1. We're going to iterate backwards over our array, starting at index 3. The next thing we're going to do is get the product of result at I. So see how I equals 3, where in this resulting array, it's going to be equal to times the postfix right here. So 6 times 1 is going to be equal 6. So that number won't change, okay? Now see how we update the postfix, because we want to be able to store the running product up here, okay? And update it every time we go through the loop. So now if we multiply the postfix times the nums at that index 3, so see how nums at index 3 equals 4. So 1 times 4 is going to be equal 4, and postfix is going to become 4. Great. Now we go back up there, and we're going to move 3 to index 2. So now we are standing on index 2 right here. So we are at 3. Now the resulting array at that same index 2, okay, it's equal to 2, is going to be multiplied by the postfix right here, which is 4. So that number should become 8. Great. So now we have, the two products from the right side after we calculate it from the right. To that point, we're good. Now we update the postfix. Again, the postfix is going to be 4 times the nums at index 2. The nums at index 2 is equal to 3. So 4 times 3, it's equal to 12. So this number at some point should become 12. For now, it should be stored in the postfix. So let's see that happen. Perfect. So the postfix updated to 12. We haven't looped yet through that resulting array, but that resulting array should store that 12 at some point. Perfect. So we move to that point. It's stored there. Now see how the postfix get multiplied by 2. 12 by 2, 24. So it stores here. So 1 should really become 24 at some point, because when we multiply 24 by 1 equals 24. So we're at index 0, 24. And that's pretty much a resulting array here. We haven't returned it yet, but we see how it looks so far, and that should be good, okay? We're done with our loop. We go down to the returning array, and we just basically return that array, and that should be the result. I wanted to show how the algorithm works in the back end. I wanted to show how it works here. This is a cool tool to do that. Let me know if you like this. Let me know if you'd like to see more explanations like this. I would love to do that. It's really easy to visualize how things are working in the backend. But let's go ahead and run our problem and see if we pass the test. Not the best results here, but obviously that's not always what you're looking for here. Let's analyze that complexity and make sure we're a big O of n, which is great for what they're asking. And in memory, I'm not sure if this would compute the way they want it, but yeah, it did. It's constant time, so it doesn't count. So technically we solved the problem under the constraints. We saw how we could do this in different ways, either creating a left pointer and storing the product on that left pointer, or simply just saying, you know, the answer at that particular index is going to be always equal to the previous product. And then for the postfix, we did that calculation there, making sure that the most important part is that we update the postfix down here. And that's pretty much the solution for this problem. Guys, if you enjoyed this video, if you like the content, please like, thumbs up, and subscribe. Let's go ahead and get it done. Let's go ahead and get that job, and I hope you enjoy it. Again, thank you so much for your time, for watching this video. I'll see you in the next one.